Students, welcome to lesson 1 of module 5. This is the first topic in module 5, potentiometer. A potentiometer is an instrument designed to measure an unknown voltage by comparing it with a known voltage. You have already in your plus 2, and I think in physics lab you may be done some experiments to find the potentiometer. The known voltage may be supplied by a standard cell or any other non-voltage reference source. That is, standard voltage we are setting using a standard cell, and we are finding the unknown voltage by comparing with this known voltage. It is extensively used for the calibration of voltmeters, ammeters, wattmeters, etc. Then we can see what are the characteristics of potentiometer. A potentiometer measures the unknown voltage by comparing it with known voltage rather than by actual deflection of the pointer. We know that using moving iron, moving coil meters, that is ammeter, voltmeter, wattmeter, what they are doing, we are finding the value of voltage by or current or whatever be the parameter, we are finding by seeing the pointer of the scale. But in case of potentiometer, there is no deflection of pointer. Instead, we are measuring by comparison. So this comparison ensures a high degree of accuracy. As potentiometer measures using null or balance condition, there will not be any power consumption. We know that Wheaton bridge is a type of potentiometer. We are using a balance condition. Hence, no power is required for measurement. Determination of voltage using potentiometer is independent of the source resistance. Okay. Next, there are two types of potentiometer, DC and AC potentiometer, and in this lecture I am discussing about DC potentiometer. So this is the main application of potentiometer: calibration of ammeter, calibration of voltmeter, calibration of wattmeter, measurement of resistance and measurement of power. And we are discussing in this module about DC potentiometer, and there are mainly two types: slide wire potentiometer, or another name is basic potentiometer. Next one is Crompton DC potentiometer. So in this video we can see the working of a slide wire or basic potentiometer circuit. This is the circuit of a basic slide wire potentiometer or basic potentiometer. This is the slide wire, or this is the potentiometer. Okay, around it will be having a length of 200 centimeter, and we are connecting a battery and a rheostat to adjust the current through this slide wire. So this is the initial arrangement, and this forms the primary circuit. A slide wire, this is a resistive wire. Length of approximately 200 centimeter. It is made up of manganese, and there is a battery and a rheostat arrangement. This form the primary circuit. This circuit will not be changing. And what is the purpose of rheostat? We are sending a known current, or to set an initial current through this circuit, we are using a potentiometer. Next, in this other side, there are two positions. One is calibrate position and another one is the operate position. Then there is a switch key which is connected to sliding contact. When the key is connected to the sliding contact, then this portion AC is selected. If the jockey is moved through another point, then that particular distance is selected, and that voltage will be your E1. Let unknown EMF be this. Here is your unknown EMF, and this is your standard EMF. So there are two methods to find the unknown EMF. First is in this method, to find the unknown EMF, the battery B1 whose EMF is to be measured is connected in series with a galvanometer G. This is the unknown EMF whose value should be measured, and it is connected in series with the galvanometer and switch key. So this is the first arrangement. In order to find the unknown EMF B1, you are connecting it with switch as a galvanometer in series with the switch, and it is connected to the key. When key is opened, that is no contact between the slide wire and key, and the sliding contact is at position C. Suppose here we be the sliding contact position. Let the current through slide wire is I ampere. So using rheostat, you are passing a current of I ampere through the slide wire. Length of slide wire AC. This be the length of slide wire AC. Let it be L unit. Okay, so this length be L unit. Resistance per unit length of wire be R ohm. Total length is 200 centimeter. For unit length, that is for 1 centimeter, let it be R ohm. So what will be for 200 centimeter? R into 200. Or if it length will be 100 centimeter, what will be the total resistance? Small r into 100. If L is the length of the slide wire, that is up to this particular point, let L be the length. So what will be the total resistance? Small r into L. So resistance per unit length of slide wire is R ohm. Then the voltage drop across AC. This is voltage drop E1. Voltage drop across the AC E1 is given by, how will you find? Current into resistance. What is the current? I ampere is flowing through the circuit. What is the resistance of the circuit? Small r into length of AC. What is length of AC? L unit. So AC equal to I into small r, resistance per unit length into total length. So voltage drop E1 is obtained. Next, you have to consider the switch key is closed. Next case is this key should be closed. So I have connected it using a wire. This key is closed, which put the battery B1 in the circuit. So which circuit come into contact with the slide wire? So battery B1, unknown EMF is connected. The battery B1 whose EMF is to be measured is connected such that voltage drop across slide wire and EMF of B1 oppose each other. You have to connect this battery in such a way that this battery voltage and this battery voltage is in opposite polarity. That means if this is negative, here also it should be negative. See, in standard cell it is negative, so here also B1 should be negative. Adjust the sliding contact such that galvanometer shows zero deflection. Next you have to move the sliding contact. Move the sliding contact to some position such that galvanometer shows zero deflection. The deflection in galvanometer G depend upon the magnitude of voltage drop across the slide wire portion AC and EMF of B1. And this galvanometer reading depends on the voltage across slide wire. If galvanometer shows zero deflection at this point AC, means this galvanometer reading deflection depend upon this voltage E1 and this voltage, that is battery voltage E. If these two voltages are same, galvanometer shows zero deflection. If E1 is more, it will deflect in one direction. If E is more, this will deflect in other direction. So if both the voltages are same, then galvanometer shows zero deflection. Measure the length of portion of slide wire with the help of scale provided. So you have moved the sliding contact till galvanometer shows zero deflection and measure the value of that distance. Consider if it is AC at point AC or at distance AC, let the galvanometer show zero deflection. And what is the EMF induced, or what is the EMF voltage across this AC? The unknown voltage across the AC we have already found that E1 equal to I into I is current through the circuit, small r into length of AC, that is I into R into L. That means E1 is same as your E. then only galvanometer shows zero deflection. So the EMF of battery V1 is unknown. EMF is given by E equal to I into R into L, which is same as your E1. Okay, this is one method of finding the unknown battery, that is without using the standard cell. Next method to find the unknown EMF is by comparing it with the standard EMF. For this, if EMF of two batteries B1, B2 are to be compared, then insert the first battery in series with the galvanometer. So first battery, let it be B1. So let you are connecting B1 initially in series with this galvanometer. Then adjust the sliding contact such that no current flow through the galvanometer shows zero deflection. So what we have to do, initially connect B1 to the switch, then adjust the slide wire so that galvanometer shows zero deflection. Measure the length of that sliding contact, let it be L1. Next step is you have to switch this S to B2 position, which is the standard battery. This value which we know, this is the standard value of battery. So you have to connect S in this position and move the sliding contact so that galvanometer shows zero deflection. So suppose another position galvanometer shows, let it be L2. That is galvanometer shows zero deflection at a distance L2. L1 is the distance at which galvanometer shows zero deflection when the galvanometer connected to battery B1, and L2 be the distance at which galvanometer shows zero deflection when S is connected to or galvanometer connected to standard battery B2. Let EMF of batteries B1, this is B1, this is B2, be E1 and E2 respectively. So in this figure, see, so let E1 be the voltage of unknown EMF B1 and E2 be the voltage across standard EMF. Okay, we know the value of E2, but E1 is unknown value. So what is the equation for E1? As per our previous equation, it is I, current through the circuit, into R, resistance per unit length, into L1. That is the length at which galvanometer shows zero deflection when connected to unknown EMF. Similarly, E2 equal to I into R2 into L2. From the equation, it is clear that ratio of two length give the ratio of 2 mmf. So take the ratio of these two, E1 by E2 equal to IRL1 by IRL2. IR is constant, so same, that is you can eliminate that, remaining L1 by L2. So which is the known quantity? E1 is the unknown EMF, E2 is the standard EMF, L1 we are measuring from the slide wire, and L2 also we can able to measure from slide wire. So E1 equal to E2 into L1 by L2. So the unknown EMF can be obtained by comparison method also. Thank you.